A function generator is a circuit which is used to produce different types of waves as output. We had previously used a function generator to generate input wave for various Opamp configurations. This is Abhinav from learnelectronicsindia.com, and let's learn how to make a function generator using Opamp. To make a square wave generator, we need an Opamp in negative feedback configuration. Then we are going to connect a capacitor between the inverting input and ground. After this, we are going to connect a resistor in positive feedback configuration. And connect another resistor between the non-inverting input and ground. Frequency of the square wave is given by this formula. So to get 1 kHz square wave, let's keep C as 0.1 microfarads. Hence, by the formula, the value of R is 4.551 kilo ohms. Now let's connect channel A of the oscilloscope to the output of the Opamp and channel B to one end of the capacitor. The voltage at non-inverting input is given by this formula. Initially, let's assume Vsat is positive. Hence, the voltage at non-inverting input is V plus and is given by this formula. Now the capacitor starts charging to positive saturation voltage. When the capacitor reaches V plus value, the voltage at inverting input is greater than the voltage at non-inverting input. Hence, the output voltage drops to negative saturation voltage. Now the voltage at the non-inverting input is given by this formula. Now the capacitor starts charging to negative saturation voltage. Now when the voltage at the capacitor falls below the voltage of the non-inverting input, the output rises to positive saturation voltage. This cycle continues and we get a square wave as the output. You can change the value of R and C to vary the frequency. We know that by integrating a square wave, we get a triangular wave. So by using this principle, we will construct a triangle wave generator by connecting the output of a square wave generator to an integrator. So let's copy paste the integrator which we made in the previous video and connect the output of the first Opamp to the inverting input. Now let's connect the oscilloscope and observe the output. The output is a triangular wave of frequency 1 kHz. To change the frequency of the triangular wave, we change the frequency on the square wave by varying the R and C values. To make a sine wave generator, we will again take an Opamp in negative feedback configuration and connect a RC series network in positive feedback and connect a RC parallel network between the non-inverting input and ground. Let R1 be 25 kilo ohms, R2 be 10 kilo ohms. To get a proper sine wave, the value of R and C in the series and parallel network should be equal. The output frequency of the sine wave generator is given by this formula. To get a frequency of 10 kHz, let's keep the value of capacitor as 10 nanofarads. Hence, the value of resistance is 1.59 kilo ohms. Now let's observe the output. The output is a sine wave of 10 kHz frequency. To change the frequency of the sine wave, we can vary the value of R and C. We can use these three circuits along with other supplementary circuits to make our very own function generator. You can find detailed explanation along with multisim file at our website link in the description. This is Abhinav from learnelectronicsindia.com. Thanks for watching.